Okay, so I just thought I'd make this quick video. This is on the second set of your homework, and it is question D. So section 2, question D, where they give you a bunch of different specific heat capacities for going for water, copper, and glass. Okay, so this was flagged to me by Amuka, so thank you very much. We had a 1 kg block of copper put into 2 kgs of water. Let me zoom in on this a little bit. How much energy would be needed to increase the temperature by 10 degrees Celsius? Well, I just said I'd slightly refine the question just a small little bit to say how much energy would be needed to raise the temperature of the system. In other words, the whole thing by 10 degrees Celsius. So if you can imagine, you've got your 1 kg copper sitting in a bath of water that's 2 kgs or 2 liters of water with your copper sitting inside. So I'll just run you through how this calculation goes, because this is kind of a setup for the further questions that are on this section. Okay, so the question is asked to find the amount of energy. Okay, so the total amount of energy that we will need should be the energy that we would need to raise the temperature of the water plus the energy that we would need to raise the temperature of the copper. Okay, so you can split these up separately if you wish, and then add them up at the end. But I'm just going to do it all in one calculation. Okay, so we would have, we know that the energy required for the water would be the mass of the water times the specific heat capacity of the water times the change in temperature for the water. And we also know that the energy required for the copper separately should be the mass of the copper times the specific heat capacity of the copper times the change in temperature for the copper. Now, it just so happens that the change in temperature for the copper and the change in temperature for the water is actually the same. Okay, in this example, it's 10 degrees. So that means I can start putting in some numbers. I've got 2 kgs of water. The specific heat capacity is 4180. For water, I've got 10 degrees. Then I do the same thing for copper. This time I only got 1 kg of copper, only 390 joules per kg per degree Celsius for the copper, and a change in temperature of 10 degrees Celsius. Now, if you follow through the units, and this is a really, really good habit, is to follow through the units on this just to see what units are on your answer, then your degrees Celsius will cancel out, your kgs will cancel out on both of them. So that means you have a total for the water of 83,600 joules. And for the copper, you would have only 3,900 joules. Okay. Notice the water is so much more. So that means that the total energy required would be 87,500 joules. So I hope that makes a bit of sense. And this kind of, like I was saying, this kind of sets up for the following questions in this section. So please make sure that you understand this. All you're really doing is you're calculating the amount of energy required for each individual one, and then just adding them all together. And like I said, you can do it all individually if you wish, and then just add up the totals at the end, or total them at the end. Or you can put it all into one calculation like I'm doing here, and just total it all like that. Okay? Thank you.